Welcome dear student and Jai Swami Narayan. In the first lecture of the chapter number 7, we will discuss about a system of the particles, rotational motion and some basic concept of the center of mass. Dear student, center of mass is a point in the system of the particle where whole the mass of the system of particle is concentrated. Or we can say that the center of mass is a point where which whole the mass of the rigid body is concentrated at that point. So dear student, today in this video we will discuss about how we can calculate the center of mass in a system of the particle, in a rigid body, right? So let us see how we can calculate the center of mass in a system of the two particles, center of mass of the system of the n particles, right? So dear student, in the previous video, we were discuss about a center of mass in a one dimensional. So for that, consider the two objects of a mass m1 and m2 situated at a distance x1 and x2 from the origin. So how we can calculate the location of the center of mass, the distance of the center of mass, or we can say that the location of the center of mass from the origin, right? Origin must be necessary to specify, right? Because the center of mass is depends on the origin. If you change the origin, the center location of the center of mass will be changed, right? So the location of the center of mass, or we can say that the distance of the center of mass from the origin can be obtained by a formula xcm. Cm is stands for the center of mass and x is the distance of the center of mass from the origin is calculated by a formula m1x1 plus m2x2 divided by m1 plus m2. So dear student, here the center of mass depends on the mass of the object and the distance from the origin. So center of mass depends on the mass distribution, right? So center of mass depends on the origin. If you change the origin, the location of the center of mass will be changed, and the center of mass depends on the mass distribution in the system of the particle and mass distribution in the rigid body. The center of mass of the system of object is closer to the object having a larger mass. So center of mass is a closer to the objects having a larger mass. So this formula is extended for the n particles, right? The center of mass of the system of n particles xcm is calculated by the formula xcm is equal to m1x1 plus m2x2 up to mn right, divided by m1 plus m2 up to mn, right? So this formula can be represented in the form of the sigma xcm is equal to sigma I is equal to 1 to n mi into xi divided by sigma I equal to 1 to n mi, where m1 plus m2 plus m3, m1 m2 m3 up to mn is the mass of the particles and x1 x2 x3 up to xn, that is the position of the particle, or we can say that the in the one dimension distance of the particle from the origin, right? So this is the formula. This way we can calculate the center of mass, right, in a one dimension. To calculate the center of mass, we require only two things. Which two things? First one is the mass of the particles, or we can say that the mass of the objects, and second one is the distance of the object from the origin, right? Now we take a one special case, right, to calculate the center of mass. If the two objects having the same mass is at a distance x1 and x2 from the origin respectively. So if we consider the two objects which are in a same in a mass of the both the object are same, situated at the two different distance. First one is at a distance x1 and second one is at a distance x2, right? Now, how we can calculate the center of mass? The center of mass xcm is equal to m1x1 plus m2x2 divided by m1 plus m2. But here, mass of both the objects are same, right? So we take m1 is equal to m2 is equal to m, right? So xcm is equal to m into x1 plus m into x2. M we take common, x1 plus x2 divided by m plus m, that is the 2m. Cut out. Xcm, the center of mass of the two objects having the same mass, is at a x1 plus x2 divided by 2. So the location of the center of mass of the two objects having the same mass is at a x1 plus x2 divided by 2, is at a midpoint, right? So understand, dear student, how we can calculate the center of mass of the two objects, center of mass of the system of the particle. Let us take one example to understand more about how we can calculate the center of mass, right? So first example, two objects having a mass 10 kg. Mass of the first object is a 10 kg and mass of the second object is a 20 kg. Two objects having a mass 10 kg and 20 kg is situated at a distance 20 centimeter and 40 centimeter from the origin. Calculate the center of mass of the two objects, right? So from the origin, m1 is given to you 10 kg, x1, the distance of the first object from the origin is a 20 centimeter, the m2 is a 20 kg, and the distance of the second object from the origin is a 40 kg, right? Calculate the center of mass. So put the formula of the center of mass. xcm is equal to m1 x1 plus m2 x2 divided by m1 plus m2, right? So given a data m1 is equal to 10 kg, so we put a 10 into x1 20 centimeter plus m2 20 kg, x2 40 centimeter divided by 10 plus 20. So we get a 33.33 centimeter. Here the center of mass is a distance from the origin. So the unit of the center of mass is a centimeter, meter and that things, right? So here the dimensional formula of the center of mass is a L1, right? So this way we can calculate. So if you think about this, the center of mass, the 10 kg object is at a distance 20 centimeter, 20 kg object is at a distance 40 centimeter, and the center of mass is at a distance 33.33 centimeter from the origin. So think about it. The location of the center of mass is nearer to the 20 kg object having a mass 20 kg, right? So the center of mass, the location of the center of mass is closer to the object having a larger mass, right? Same thing, we take the one another example. So now dear student, we will take one another example to calculate the center of mass. The distance between the carbon atom and the oxygen atom in the carbon monoxide is a 1.13 angstrom. Calculate the center of mass of the CO molecules with respect to carbon atom as well as with respect to oxygen atom, right? So here the center of mass of the carbon monoxide molecules, CO molecules, with respect to carbon atom is a different, and with respect to oxygen atom is a different, right? So first we calculate the center of mass of the CO molecules is with respect to carbon atom. If you want to calculate the location of the center of mass of the CO molecule with respect to carbon atom, we take the carbon atom is at a origin. So the position of the carbon atom is xc is equal to 0 and the oxygen atom is at a distance xo is equal to 1.13 angstrom, right? So now if we want to calculate the location of the center of mass with respect to oxygen atom, so we take the oxygen atom is at a origin, so we take a xo is equal to 0. The location of the oxygen atom is 0 and the xc is equal to 1.13 angstrom, right? So to calculate the center of mass, we require two things. Which two things? Mass of the particles and the distance from the origin. So first we calculate the center of mass of a carbon monoxide with respect to carbon atom. So we place the carbon atom is at a origin. So the distance xc is equal to, we take 0. The mass of the carbon, you know that 12 gram, and mass of the oxygen is a 16 gram, and the oxygen is at a distance xo 1.13 angstrom, right? So similarly, we put a formula, xcm is equal to mass of the carbon, xc distance from the origin, but here the carbon is placed at a origin, we take a distance xc is equal to 0, plus mass of the oxygen 16 gram, and distance of the oxygen from the origin is 1.13 angstrom, divided by mass of the carbon plus mass of the oxygen, 12 plus 16. So we calculate 16 into 1.13 divided by 28. So xcm, the location of the carbon monoxide atom from the carbon atom is 0.645 angstrom, right? So the carbon, the center of mass is at a distance 0.645 angstrom from the carbon atom. So from the oxygen atom, how we can calculate the from the oxygen atom? We take the oxygen is at a origin. So we take a xo is equal to 0, mass of the oxygen and mass of the carbon is same, and xc is equal to 1.13 x1. Same formula if you put and calculate the xcm, you get a 0.484 angstrom. So the location of the center of mass in a carbon monoxide CO molecules is at a 0.645 angstrom from the carbon atom and 0.484 angstrom from the oxygen atom, right? So here the location of the center of mass is depends on the origin, what we take for the origin. So here the center of mass from the carbon atom is 0.645 angstrom, and the location of the center of mass from the oxygen atom is at a 0.484 angstrom. Understand, dear student, how we can calculate the center of mass with respect to the origin, right? Same example, similar example given in your textbook exercise that you have to solve by yourself. In the textbook exercise, example number 7.2 is given to you, right? You have to calculate by yourself. Similar, in the HCl molecules, the separation between the nucleus of two atoms is about 1.27 angstrom, right? So the distance between hydrogen atom and the chlorine atom is a 1.27 angstrom. Find the approximate location of the center of mass of the molecules. Given that the chlorine atom is about a 35.5 times the massive as the hydrogen atom. So we take the mass of the hydrogen atom is a 1 gram and the mass of the chlorine atom is a 35.5 gram, and nearly all the mass of the atom is concentrated in its nucleus. So here similarly to the previous example, take the distance between the hydrogen atom and chlorine atom is a 1.27 angstrom, right? Mass of the hydrogen atom is a 1 gram, mass of the chlorine atom is a 35.5 gram, right? And calculate the location of the center of mass from the hydrogen and the location of the center of mass from the chlorine. As in the previous example, location of the center of mass from the carbon atom and the location of the center of mass from the oxygen atom. You have to calculate. So this example you have to calculate by yourself. Exercise example number 7.2. Understand, dear student? So now we will take another example. From a multi-story building, four objects having a different mass, 400 gram, 150 gram, 1000 gram and 600 gram, are released from the multi-story building. At the some instant of the time, the object having a mass 400 gram is at a second floor. The object having a 150 gram is at a fourth floor. The object having a 1000 gram is at a sixth floor, and the object having a mass 600 gram is at a 8th floor. Calculate the center of mass look of the system of these four objects. So what is the location of the center of mass for the system of these four objects? So here we need to calculate the center of mass. To calculate the center of mass, we require two things: mass of the object that are given to you and the position of the object that is also given to you. So the center of mass, location of the center of mass is taken as a YCM is equal to M1Y1 plus M2Y2 plus M3Y3 plus M4Y4 divided by M1 plus M2 plus M3 plus M4. So here in the vertical direction we take a Y. You can also take a X, M1 X1, M2 X2, M3 X3 plus M4 X4 divided by M1 plus M2 plus M3 plus M4. So here the mass of the first object is a 400 gram and its location is at a second floor. So we take a 2 from the ground, right? Mass of the second object is a 150 gram and the location of the second object is at a fourth floor. So we take a 4. Similarly, mass of the third object 1000 gram and the location from the ground is a sixth floor. So we take a 6, right? Plus mass of the fourth object is a 600 gram and its location is a 8th floor. So we take a 8 divided by total mass 400 plus 150 plus 1000 plus 600, right? So if you calculate this, we get a YCM is equal to 5.67, right? So the center of mass is at a 5th floor. The location of the center of mass is at a 5th floor or between a 5th floor and the 6th floor, nearer to the 6th floor. Approximately we can say that the center of mass, location of the center of mass is at a 6th floor, and as you know that the center of mass is nearer to the object having a larger mass, right? So understand, dear students, this all the examples of the center of mass, how we can calculate the center of mass in a one dimension, right? Now we will discuss the center of mass of the system of n particles in a two-dimensional and the three-dimensional, right? So we will take the next point, that is the center of mass of the system of n particles in a three dimension. So dear student, here the location of the particles in the two dimension and the three dimension is represented by a position vector, right? So here how we can calculate the center of mass? Look, the position vector of the center of mass of the system of n particles in the three dimension. So in the one dimension we use the either x coordinate or a y coordinate, but in the two dimension and the three dimension the location of the objects, the location of the particles is represented by a position vector, right? So consider the xy coordinate system, and in that consider a system of n particles m1 m2 having a mass m1 m2 m3 up to mn and has the position vector r1 r2 r3 up to rn. So center of mass in the system of n particles is the position vector of the center of mass is at a rcm, right? So consider a system of n particles in the xy coordinate system having a mass m1 m2 m3 up to mn. The position vectors of the particles is a r1 r2 r3 up to rn. So in the two dimensional and the three dimensional we need to position vector, right? X coordinate is there, y coordinate and z coordinate in the three dimension, and two dimension x and y coordinate are there, right? So the position vector of the particles are r1, that means the x coordinate of the first particle is a x1 y1 x2 y2, right? Like this. So the center of mass, the position vector of the center of mass is given by the formula RCM is equal to m1r1 plus m2r2 plus up to mnrn divided by m1 plus m2 up to mn, right? Similar, in the previous one dimensional we use the m1 x1 plus m2 x2 plus only x coordinate we take, right? Similarly, y coordinate will taken. So in this situation, in the two dimensional and the three dimensional, we take the position vector RCM is equal to M1R1 plus M2R2 plus M3R3 up to MNRN divided by M1 plus M2 plus M3. So here in the two dimensional and the three dimensional, we represent the position in the form of the vector. That is the only difference, right? RCM is equal to sigma I is equal to 1 to n mi into Ri divided by sigma I equal to 1 to n mi, where sigma I is equal to 1 to n mi is equal to total mass of the particles, right? So we take a capital M. So RCM is equal to 1 by m sigma I is equal to 1 to n mi into Ri, right? Or we can write like this: M into RCM is equal to M1R1 plus M2R2 plus up to MNRN, where capital M is the total mass of the system. So the x coordinate in this RCM, three coordinate of the center of mass is present: x coordinate, y coordinate and z coordinate, right? So x coordinate, if you want to find the x coordinate of the center of mass, we take the x coordinate of all the position vector. If you want to find the y coordinate of the center of mass, we take the y coordinate of all the position vector. And if we want to find the z coordinate of the center of mass, we will take a z coordinate of all the position vectors, right? So understand how we can calculate the center of mass in a two dimensional and three dimensional. So now dear student, we will take one example. Example, the three particles of a mass 1 kg, 2 kg, 3 kg have a position vector 1, 2, 3 meter. So first particle has a position vector 1, 2, 3 meter, right? X coordinate is a 1, y coordinate is 2 and z coordinate is 3. Second particle, mass of the second particle M2 is 2 kg. The position vector R2 is a 4, 5, 6 meter. And third particle having a mass 3 kg and a position vector 5, 6, 7 meter. Calculate the position vector of the center of mass. So from the above formula, RCM is equal to M1R1 plus M2R2 plus M3R3 divided by M1 plus M2 plus M3, we can easily calculate the position vector of the center of mass, right? So here M1 is a 1, R1 is a 1, 2, 3 plus M2 is a 2 kg, R2 is a 4, 5, 6 plus M3 is a 3 kg and R3 is a 5, 6, 7. So first, how we can calculate this? First, this 1 is multiplied into all the three coordinates. So this one is the vector addition, not a simple addition, right? So if you multiply 1 to the 1, 2 and 3, we get a 1, 2, 3. X coordinate 1, y coordinate 2 and z coordinate 3. Similarly, 2 is multiplied all the three coordinate of the R2, right? So 2 4 is 8, 2 5 is 10 and 2 6 is 12 plus 3 5 is 15, 3 6 is 18 plus 3 7 is 21. Now add the x coordinate of all the vectors. So 1 plus 8 plus 15, you get a x coordinate of the center of mass 24 divided by 6, right? 2 plus 10 plus 18, you get a 30 and 3 plus 12 plus 21, you get a 36 divided by 6. So 24 divided by 6, you get the x coordinate of the center of mass 4. 30 divided by 6, you get the x coordinate of the y coordinate of the center of mass 5 and 36 divided by 6, you get the z coordinate of the center of mass 6, right? So this, in this situation, in the three dimensional or two dimensional or three dimensional, you have to take care of this addition of the vector, right? So here you have to add the vector addition, you have to use the vector addition, right? Now we will take one another example. Calculate the center of mass with respect to M1. The figure is given to you, a equilateral triangle is given to you having a side A, right? Any other side is also may be given in a examination, 2 centimeter, 3 centimeter, or any, right? So object having a mass m1, object having a mass m1, m2 and m3. So this way the mass of the object is given to you 1 kg, 2 kg and 3 kg. Sides of the equilateral triangle is given to you A, like A, right? Calculate the center of mass with respect to m1, right? So here the m1 we place at the origin, right? So mass of the first object m1, the position vector of the first object is 0 0. Why? Because we need to find with respect to the mass m1, right? m2, second object, position vector of the second object m2 is a x coordinate is a and y coordinate is 0. And third position, the mass of the third object m3, x coordinate of the coordinate position vector of the object having a mass m3 is, how we can calculate? X coordinate we take a cos 60 and y coordinate we take a sin 60. So the magnitude a cos 60 and a sin 60. So value of the cos 60 you know 1 by 2. So x coordinate of the third position vector we get the a by 2 and sin 60 root 3. So y coordinate we get a root 3a by 2, right? Understand? Now mass is given to you, position vector you are find, right? Now put the formula of the center of mass. The center of mass RCM is equal to m1 r1 plus m2 r2 plus m3 r3 divided by m1 plus m2 plus m3. Now put the value, right? m1 0 0 plus m2 a0 plus m3 a by 2 root 3a by 2. Now multiply m1 m2 m3 inside the vector, we get the m1 0 m2 0, right? So 0 0 there is no meaning. So here x coordinate, how you find the x coordinate? m1 into 0, that is 0, m2 into a plus m3 into a by 2. So we get the x coordinate m2a plus m3a by 2. Y coordinate m1 into 0 0, m2 into 0 0 and m3 into root 3a by 2. So y coordinate we get the m3 into root 3a by 2 divided by m1 plus m2 plus m3. So this way we can get the position vector, x coordinate of the position vector and y coordinate of the position vector. So dear student, understand this example. You have to try the similar example given below, right? So here the mass of the object 1 kg, 2 kg and 3 kg is given to you. Equilateral triangle is there, right? And the sides of the equilateral triangle is a 2 centimeter, right? The same way the m1 with you take a 1 kg, r1 0 0, m2 2 kg, r2 the side of the equilateral triangle 2 centimeter. So x coordinate is a 0 and y x coordinate is 2 and y coordinate is 0. m3 r3 2 cos 60 2 sin 60 and put all the value and calculate the center of mass, right? Same example is given in your textbook. Example number 7.1. Find the center of mass of the three particles at the vertices of an equilateral triangle. The mass of the particles are 100 gram, 150 gram and 200 gram. Each side of the equilateral triangle is a 0.5 meter long. So similar example given in the textbook, example number 7.1, you have to solve by yourself. So here you have to take the mass m1 100 gram, mass m2 150 gram, mass m3 200 gram. The sides of the equilateral triangle 0.5 meter. So m1 is put at the origin. So the position vector of the first particle r1 is equal to 0 0. Position of the vector of the second particle r2 is equal to 0.5a and position vector of the third particle is 0.5 cos 60, 0.5 sin 60, right? So you have to calculate by yourself by putting the formula RCM is equal to m1 r1 plus m2 r2 plus m3 r3 divided by m1 plus m2 plus m3. Previous same example you have to solve all the three examples, right?